You're listening to After the Show, a Signals Everywhere podcast, where we teach you everything you need to know about software-defined radio. In today's episode, we'll be covering the launch of Sdr QO100, some of my favorite recent posts from the Rtl-Sdr blog, and finally answering the age-old question, what SDR should I get? I'll be your host, Corrosive. I'm an amateur radio operator with my extra class license and the founder of the Signals Everywhere YouTube channel, where I create tutorials, demonstrations, and reviews of software-defined radio topics and projects. We all love amateur radio satellites, but let's be honest, there's only so much that a low Earth orbiting satellite can do for us. Wouldn't it be really amazing if you had access to a geostationary satellite, one that didn't move from its slotted location, so you had access to it 24/7, 365? Well, for those lucky licensed operators within the footprint from Brazil to Thailand, this is finally a reality. With the launch of Sdr 2 from the Kennedy Space Center on Thursday, November 15th of 2018, this satellite has now been commissioned for amateur radio use as QO100. This is the first amateur radio satellite that has ever been launched into a geostationary orbit. At a orbital slot of 25.9 degrees, this gives us a footprint that covers entire continents. Unlike a low Earth orbiting satellite which constantly moves around the Earth, this one will stay steady over its current position, locked into place. This means that you will have 24/7 access within the footprint of the satellite to make contact with any other amateurs. This is going to be using a 2.4 gigahertz uplink as well as a 10 gigahertz downlink, meaning that receiving the satellite is as simple as having a dish with a traditional 10 gigahertz LNB. And you could use anything from a traditional radio to software-defined radio for both receive and transmit. Now, this satellite is also unique in the fact that it has two transponders on board, a narrowband transponder and a wideband transponder. The narrowband transponder is 250 kilohertz wide for sideband voice, and I'm sure you could do other things with this as well, such as RTL, PSK, or other communication modes that take up a very small amount of bandwidth. The other transponder is 8 megahertz wide, intended for experimental modes and DVB-S. And if you're not familiar with that, that is actually digital amateur television. You can actually send up a video signal to this satellite and have it retransmitted to everyone within the footprint of that satellite. A truly amazing thing that we really didn't have the capability of doing prior. The launch of Sdr 2 and commissioning of QO100 marks an amazing milestone for the amateur radio community as a whole. We now have the ability for 24/7, 365 communications through the satellite and the ability to provide better emergency communications. And let's not forget, we now have an amazing platform for us to use for experimentation. Never before has an amateur radio operator had the ability to access a satellite of this magnitude, and I can only imagine where this technology will take us in the very near future. Now, I am an avid reader of the Rtl-Sdr blog, not only because I find it to be an amazing resource for finding new and interesting projects, but especially for those who are new to the hobby. And I know this was the fact in my case, I got this new radio and I didn't really know what to do with it. And so the Rtl-Sdr blog was really a cool way for me to find interesting little things that I could do with my new software-defined radio and quickly put it to use. And so I wanted to share a couple of things that I found posted on the blog recently with those here listening on the podcast. One of the first things that caught my eye was this 3D printed V-dipole holder for the Rtl-Sdr blog's multi-purpose dipole kit. And if you're not familiar with it, it's a very versatile dipole antenna. It's essentially a set of rabbit ears like you might be familiar with on old analog television sets, but it has a nicer piece of feed line on it so that you can use it for higher frequencies. And it's a very versatile antenna. However, Adam 9A4QV, someone you may be familiar with as the developer for the LNA for All, wrote about on his website how it could be used in a V-dipole configuration as a simple and effective antenna for receiving weather satellites like NOAA and Meteor M2. And in my own personal experience, it's also an amazing antenna configuration for receiving UHF SATCOM as well. And a lot of people seem to be having trouble figuring out exactly how far apart these elements need to be on the dipole to give them that V-dipole configuration. And it does have to be very precise at about a 120 degree angle. And even if you're able to find that angle, if you want to use this in a more permanent installation, you need a good way to hold the antenna at that configuration. And so this 3D printed V-dipole holder is a really amazing and simple way that you can just 3D print a holder zip tie it to your antenna, and it will keep it in the V-dipole configuration for you, so you don't have to worry about the antenna elements flailing around in the wind or getting offset from where they were originally. And it's just a very simple yet elegant way to solve a problem. There's going to be a link to this in the show notes where you can find this on Thingiverse if you want to 3D print your own. And with that, I want to go on to the next project I found on the blog, which is the Rad Wave Beta. It's an Android Rtl-Sdr RF analyzer application that has a couple of different features like spectrum pausing and rewinding. What I find so interesting about this is we have not had a decent RF analyzer application for the Android platform and SDR since the original RF analyzer application was released. And for those of you that use it, you know there really hasn't been an update to it in quite a long time. So to find out that RadWave is developing their own analyzer software is just truly amazing, because we should be seeing more frequent updates now, and it should allow us to do a lot more with software-defined radio using our Android devices. I also find it pretty cool that this has spectrum pause and rewind features, where you can actually have a history of your spectral waterfall and rewind that to some time in the past, essentially a way to replay an IQ file on the fly. And I'd love to see where he's going to go with this in the near future. Just a really cool application, and I wanted to give it a quick mention here. And finally, from the blog, we have a video tutorial by the user Hub Martin on YouTube, who was showing us how to use Universal Radio Hacker and an Rtl-Sdr with a microcontroller to clone a 433 megahertz remote control. It's just really cool to see stuff like this, because Universal Radio Hacker is such an amazingly versatile piece of software where you can go in and actually reverse engineer how a particular signal was created and try to re-implement it on your own. But we haven't really seen a whole lot in terms of videos on how to do this. And even with a lot of the tutorials I tend to make, I haven't been able to do a whole lot with Universal Radio Hacker yet. So it's really cool to see videos of this nature coming out and giving us a better idea of how you can exploit and modify some of this equipment and bend it to your own needs using just basic software-defined radio. So it's really cool to see stuff like this coming out. And finally, I want to address one of the questions I hear more often than anything else, especially from new individuals to the hobby. And what they always ask me is, Corrosive, what SDR should I get? And I feel there's no better way to answer that question than by asking you, what do you want to use it for? I mean, when we started out, there were so few choices. Almost everything came from eBay. They were originally TV tuners, and there wasn't a whole lot of information about it. And today, there's a plethora of different software-defined radios out there, from the Rtl-Sdr V3 to the AirSpy, the RSP, the HackRF, the Pluto, the Lime. It's mind-boggling, and it really becomes difficult, especially for the new user, to figure out what type of SDR should I get, how much money should I spend on it. And so it really comes down to that question that I asked originally is, what do you want to do with your software-defined radio? So every time I ask this question, I usually get an answer that puts somebody into one of several categories. Either they want to receive something, they want to transmit, or they want some combination of the two where they can do both transmit and receive in either full or half duplex. In those situations, the question then becomes, what exactly do you want to receive and what frequency range do you need? The tuning frequency range that you're going to need for your software-defined radio is going to vary a little bit depending on what it is you're looking to do. For the vast majority of users in software-defined radio, really what you need is a general-purpose receiver. You might be looking to do a little bit of HF. You might want to do L-band receive up at 1.5 gigahertz. Maybe you want to track some aircraft with ADS-B at 1.09 gigahertz. Or maybe you want to do something with ATC or P25 trunking. For things of that nature, you're going to fall into that general receive range, and the vast majority of software-defined platforms out there will cover this quite nicely. You're going to have a few different options, but the main ones here that I often see talked about is going to be the Rtl-Sdr V3, and this comes in a couple of different price points. If you're on a budget, you can actually get the SDR itself for just $21, but for $29, you can also get it with the antenna kit, and it's been said time and time again that your antenna is the most important part of your radio system. So if you're new to SDR, having that antenna kit is very, very nice and very helpful, and of course they do sell it separately if you want to use it with a different software-defined radio. Now, the cool thing with this one is it has something called Q-branch or direct sampling. This lets you receive 500 kilohertz to 28.8 megahertz making the radio capable of receiving HF frequencies, in addition to tuning up to 1.766 GHz with traditional sampling. This software-defined radio also includes a bias T, which is selectable in software. A bias T essentially is going to allow you, in this case, to send 4.5 volts up through the antenna line. If you're looking to do something with, say, L-band, Iridium, or Inmarsat, this can be very helpful because you can use a bias T to power an LNA for general receive, or the LNA on a patch antenna that you might use for SATCOM in the L-band. So those really do come in handy. You don't have to provide your own power injector in those cases. The Rtl-Sdr V3 through the Rtl-Sdr blog supports a max sample rate of 3.2 MHz, meaning that you can look at any swath of bandwidth 3.2 MHz wide anywhere along the tuning range of that software-defined radio. However, it's only going to tune about 2.4 megasamples per second or 2.4 MHz stable without dropping any samples. So if you're looking to do just analog receive, you can do that 3.2 without any trouble, but if you're looking to decode something digital, you'll want to stick to that 2.4 megasample range. But it does work quite nicely. It comes with an 8-bit ADC and is based on the Rtl-2832U. Another SDR that I see a lot of people go for is these eBay units, these really cheap software-defined radios that have RTL plastered all over the name. And while they do look enticing, I would highly recommend you avoid these ones. The reason for that is they're not going to have a bias T. They tend to be prone to failure and DOA, where they're just kind of dead on arrival. They don't have any good heat dissipation, so they're really bad at L-band, and you'll find that they kind of drift in frequency, or they begin to overheat and they're not able to tune in the frequency you're looking for. And the reason for a lot of this is because a lot of those eBay units are still the original TV tuners that were discovered to be used as software-defined radios. So they don't have any of the enhancements that really make it a stable device for software-defined radio. A lot of these I also see coming out of China on eBay have been stuffed into a box, and more than one software-defined radio might be included in that box. And what you find with that is, bad USB connections or poor solder joints. I can't tell you how many times I've seen somebody buy an eBay unit, can't figure out why it's not working, all to find out that the solder joints were bad and they just didn't have any connection on their USB header. Another big problem with those is they don't have any ESD protection, or if they do, it's really bad ESD protection. So you put a long wire on there for HF and you blow out the receiver, or you key up a radio nearby and you just blow it up. I would highly recommend you stay away from the eBay units. You're just not going to have a good time. Now, let's say 3.2 megasamples maximum isn't enough for you. Well, in that case, you might be looking at an AirSpy or an RSP from SDR Play. Now, let's say a tunable range up to 1.766 gigahertz just isn't enough for you. What options do you have then? Well, in that case, I'm probably going to point you over to New Elec. And the reason for that is New Elec has some of the few E4000 based SDRs on the market still available. The E4000 was a chipset that has long been discontinued, and they managed to snag up the last of them. Now, these do have a tuning gap where they're not able to tune to 1.1 gigahertz to 1.2 gigahertz. However, this has a tuning range of 55 megahertz to 2.3 gigahertz. And what's so nice about that is if you have some reason that you need to tune above 1.7, let's say 1.9 gigahertz, for example, where the decked phone band is, you might be interested in a tuner like this because these E4000 tuners were able to support that range without the added cost that you would find with a more high-end software-defined radio. And you can find these for about $40, give or take. And while we're on the topic of New Elec, they also have something called the Smart T. And what that is it's an RTL-based SDR that uses the same Rtl-2832U chip used in the Rtl V3. However, the bias T on this is always on. It does not turn off for any reason. As soon as you plug in the SDR, you have that 4.5 volts going out of the antenna connection. And I use one of these in my mobile vehicle because I have an L-band antenna that is being run out to cascading LNAs. So I like to have power going to my LNA at all times rather than having to enable it in software. So for that, it is quite handy. Let's say the tuning range isn't really a problem, but you need to have a better sample rate, where 2.4 or 3.2 megasamples per second just isn't enough bandwidth for whatever it is you're working on. In that case, you might be interested in an AirSpy or an RSP. The AirSpy Mini starts at about $99. The Mini will do 6 megasamples per second, where the original AirSpy will do a full 10 megasamples per second. It also has BIOS-T support built into it, and that can be enabled or disabled using Sdr Sharp, where the BIOS-T option is actually built into the software UI itself. It is also plug and play because it is made by the developer of the Sdr Sharp software. You can simply plug it in, open up Sdr Sharp, and you're good to go. You don't actually have to go in and use the Zadig software in this case, because it is natively supported in the Sdr Sharp software. In the case of the RSP, you're going to be looking at about $110, but you get a tuning range of 10 kilohertz all the way up to 2 gigahertz and a 10 megahertz bandwidth as well. Now let's say after all of that, 2 gigahertz just isn't wide enough of a tuning range for you. Maybe you need to receive 3, 4, 5 gigahertz or more. Well, in that case, you may be looking at a Hack RF, which has a tuning range of 1 megahertz to 6 gigahertz. Now, the Hack RF is one of those more interesting software-defined radios that are actually capable of doing both receive and transmit. However, this radio is only half duplex, meaning you can receive or transmit one at a time. It's not capable of receiving and transmitting simultaneously. However, this does have an amazing 20 megahertz swath of bandwidth that you can look at a given time with a 20 megasample per second sampling rate. It has an 8-bit ADC and built-in BIOS-T support, switchable in software, which, as I mentioned earlier, will allow you to send voltage up your antenna line to a preamplifier or something else of that nature. Now, before we jump any further into the world of transmit-capable software-defined radios, there's really another question that I have to ask, and that is, what do you want to transmit, and which operating system platform are you most comfortable with? The reason for asking this is that software-defined radio inherently is going to be dependent on what your software is capable of. So depending on what you want to transmit and what operating system you're familiar with is going to dramatically change which transmit software-defined radio is going to be best suited for your purposes. One good example of this is doing digital amateur television. You can transmit a DVB-S signal for digital ATV using a Hack RF, a Pluto SDR, a Lime SDR, or any number of other software-defined transmit-capable radios out there. However, what's going to change is how you accomplish this. In the case of the Hack RF, you're going to have to actually generate your own transport stream video to send to it in order to transmit. You're also going to have to use the GNU Radio software suite, which, while very powerful, is almost certainly going to limit you to using a Linux-based operating system. And if you're a Windows user, that may be very daunting, and it could perhaps be something you're not ready to jump into yet. And while it is possible to run GNU Radio within Windows, the support under Windows really isn't there. So if you run into problems, you're going to have a hard time getting something done. Conversely, with the Pluto SDR and Lime SDR, there's a software package out there called DATV Express, which will let you transmit that DVB-S signal using either SDR simply by telling it how wide you want your signal to be and where your camera and microphone are located on your computer, and it does the rest, making it a very simple and intuitive way of doing digital amateur television. Let's say, on the other hand, you want to do a GSM base station through a dummy load just to learn about how the GSM stack works. In that case, you're probably going to want to use a Lime SDR or the Lime SDR Mini because the software support exists for that under Linux. So with that being said, aside from the Hack RF, what other transmit SDRs are there? Well, the two I would recommend are going to be the Pluto SDR and the Lime SDR. Now, the Pluto SDR runs for about $149. It has a tuning range of 325 megahertz to 3.8 gigahertz, and it is advertised to have a 20 megasample per second sampling rate. However, in my experience, it's only able to do about 4 megasamples per second stable without dropping any samples. The reason for this is it uses a 12-bit ADC, and unfortunately with USB 2.0, you're not going to be able to push out that much data on a 12-bit ADC. However, it is unique in the fact that this is a full duplex radio, meaning you will be able to transmit and receive at the same time. I've used my Pluto SDR for full duplex packet transmissions where I'm able to receive and transmit packet data at the same time, which would be really good for a TCP IP link over radio. I've also used it to build a makeshift linear translator, or essentially a single sideband repeater where I can listen to a signal on one band and then retransmit it on the other in real time. And for that, it is an amazing software-defined radio. And on the other hand, we have the Lime Mini SDR as well as the Lime SDR itself. Now, the Lime SDR Mini is going to run for about $159 without a case or $299 with the case. And if you had to choose one, I would highly recommend, if you're going to buy a Lime SDR Mini, that you buy it with the case, because what I have noticed is that the Lime SDR Mini gets very, very hot, and it is possible to fry your radio. If you can't afford to get the one with the case, I would highly recommend the Pluto SDR over the Lime. Now, that being said, the Lime SDR does have a 10 MHz to 3.5 GHz tuning range and 30 megasample per second sampling rate with a 12-bit ADC, and unlike the Pluto, it does have a USB 3.0 port, so it is very capable of pulling in that 30 megasample per second rate if you have a USB 3.0 interface on your computer and the processing power to handle it. And finally, let's say all you really want to do with your transmit software-defined radio is do some AM, some FM, and some sideband. Maybe you want to stick a filter in front of it and put it on the air under the amateur radio bands. Well, that's certainly something you can do, and for that, I would highly, highly recommend using a piece of software called Sdr Angel. It is by far the most capable application I have seen for a transmit-capable SDR. It is capable of doing both receive and transmit with your SDR, and will even let you receive from one SDR and transmit to the others. So you could, for example, use something like the HackRF, which is only going to be able to transmit or receive at a time, and pair it up with something like the Rtl-Sdr V3. So you could use your Rtl-Sdr to do your receiving and your HackRF to do your transmitting, all under the same software package. And while the HackRF is not full duplex itself, you could in fact use it as if it were with the Sdr Angel software package. Likewise, this also works with the Pluto SDR and the Lime SDR. So if you're looking to get into transmitting with a software-defined radio, I would highly point you in the direction of Sdr Angel. It works under Linux, Mac OS, and Windows. So you really can't go wrong, and of course, it's open source and completely free. With all that being said, I hope I was able to provide you guys with some insight and help you decide which software-defined radio is right for you. Please be sure to let me know if you enjoyed this episode of the podcast. I would love to do more. Take a look at our show notes and the description below. I would love to see you in the Discord server. Come be a part of the community, and maybe we'll even interview you or bring you on the next show. My name's Corrosive. This is After the Show, the Signals Everywhere podcast.